Is the PPT visible to you? This is
Yes,
the
sir.
second part of the first unit. Of course, this may take some two classes. Means one more class may require to complete this particular PPT. So by that, then first unit would be completed after that. Okay. Now look at here. I'm just switching on the full screen mode. So this is the second part, as I told you, and now the contents of the PPT. So the topics covered in this particular second part are like 2D transformations, concatenation of transformations, homogeneous representation, and 3D transformation. These are the four topics as part of the syllabus, and so you can easily understand that we are going to talk about the transformations. Okay, what do you mean by transformation? It is very simple. You don't need to worry. You all got experience on AutoCAD, working with AutoCAD software. So in AutoCAD, you already, without knowing the term transformation, actually you already did all the varieties of the transformations. You worked on all these things. For example, you try to move after creating one small object in the AutoCAD. You got a chance many times you would have moved that object from one location to another location by providing some information like on the either you can move manually by picking the object through the cursor. You can pick it and you can move it, which means through the cursor you can move it, or even you can move it through the command prompt also. So if you want to move it via command prompt, after picking the object, after entering the command move and then picking the object, then it will ask you to provide the x direction movement as well as y direction movement. So once you provide those details, the object will be automatically moved to the new location. So that is one small operation that you would have already performed on AutoCAD. So that small operation itself is called as a translation. Whatever the move command or whatever the movement that you made on AutoCAD objects, that is nothing but translation. So if you look at the first picture, there are totally four pictures here. So four different operations are shown here. All these four operations are the main types of the transformations. All four are called as transformations. But apart from these four, there may be few more operations also might be there. But these four are the fundamental transformations. These four are called as main types or fundamental transformations. So which we are going to learn today. So you might have used them in the AutoCAD, but you don't know what is happening behind the screen, what exactly is happening, how the coordinates are being calculated, how the object is actually changing from locations to location. All those things we are going to learn in the today's topic. So as I said, the main types of transformations are translation. Second one is scaling. Third one is reflection or mirror. Fourth one is rotation. You already know. You already did all these four. The first one is translation means uh, pointer. So this first picture depicts the meaning of a translation. So this is the old object. Okay, old object has been translated to another location by giving the translational distances. Dx is x direction movement, dy is y direction movement. These two things also I need to provide to the computer as an input. Then automatically computer will be in a position to move the object to a new location. So now we will discuss about how the calculations are going to happen and all these things. So before that, just try to understand, try to have a idea about all the four operations first of all. Second, transformation. So there is a difference. Transformation is different. Translation. So I want you to remember, don't get confused between these two words. All four come under transformations. First one is translation. Translation is simple movement. Second one is scaling. You already scaled up and scaled down objects. Probably you would have used a scroller button. By rotating the scroller button up and down, you can actually zoom in and zoom out. That zoom in and zoom out is a kind of scaling. Okay, though the actual dimensions of the object are not changing, but still actually you feel that the object is actually uh, uh, um, the object is actually in its size is increasing or decreasing. So such without of course there are plenty of other scaling factors also discussed. As of now, you can think that the shape of the object is not changing. Only thing is the size of the object may be increasing or decreasing. That is a simple scaling. Third type of transformation is reflection or mirror. You can see there is an old object here, a mouse kind of thing. That object, you can ask the computer to get the mirror image of that object about x-axis. If you ask the computer, this is how it will do. But of course, here I need to, what information that I need to provide about which axis I want to have the mirror image. So whether it is x-axis or y-axis, that I need to provide, and on top of that, what is the mirror distance also. Probably this mirror distance you no need to provide. Why? Because automatically once the object is available, automatically computer knows what is the distance of this particular object with respect to x-axis. It can easily calculate it on its own. You no need to provide any information. Only thing is you just need to tell about which axis. About x-axis means that is how the mirror image would be created. If you say about y-axis, then the mirror image would be created here also. If you say about origin, if you say about origin, I want to have a mirror image, then probably in the third quadrant you get the mirror image. So which means both x-axis mirror as well as y-axis mirror, both mirrors do happen. Both operations do happen. As a result, the final mirror image would come in the third quadrant. Okay, so that is about reflection or mirror. The fourth type of transformation is rotation. If you look at the object here, there is an xy axis. So now I can say that I want to rotate this particular object, about origin. Look at here. I'm taking a point actually about the origin. I am not saying that about x-axis you rotate or about y-axis you rotate. I'm saying that about origin. Right now, what are the pictures that we are talking about? All these pictures belong to two-dimensional. That is why two-dimensional transformations. So in all two-dimensional transformations, we will have only two axes. Third axis won't be there. Even the object also would be two-dimensional object. The object is not a three-dimensional. After completion of the 2D transformation, we can talk about 3D also. So try to understand, rotation is about the origin. So the object here you need to select, and then you have to provide the input information like how much angle you want to rotate. So once you enter the 30-degree or whatever the angle that you want to rotate, of course we know the notation for the providing the angle. Anti-counterclockwise direction angle is always considered as positive. So if you consider this as a new object, this as the old object, probably 30-degree counter direction rotating. Enter that details in the computer. 30-degree theta also I need to provide apart from the selection of the object. So hope you understood the four main types of transformations from the picture. Okay, is uh, is my voice audible and clear to everybody?
Yes, sir.
Yes,
Because
sir.
here I am getting some. That's good. Copying coordinates. Okay. Convert the geometry from the coordinate system. Actually, uh, if we want to talk about the coordinate system, Even the transformations also can be performed in two different ways. Here, whatever the from the picture, whatever that I explained to you so far, it is one type of transformation where keeping the in a position, only the object is actually changing its position. This is one way of performing the transformation. There is another way also where the object would be kept in its in the same position, whereas the coordinate system would be whatever the transformations, all those transformations would be applied on the coordinate system. So that is another way of performing the same kind of task. In both the situations, the new coordinates with respect to the new coordinate system would always be the same. Finally, the end result would always be the same. Okay. Now, coming to the first transformation, which is called as translation, uh, which is called as translation. I think just a minute. Actually modified, incorporated some. I made some changes actually. I don't know whether those changes got reflected or not. Okay, fine, no issue. So, if you look at the translation, where I said that let us say this is the old object, this is the old object, and this old object, I am trying to move it, translate it to new position by providing dx and dy. These are the translational distances that I need to provide. So what exactly is happening behind the screen is very simple. If you take one point on the original object, which I'm showing it like P, whose coordinates are small x, and small y. Okay, small x and small y are the old coordinates of the old object, for which I'm trying to translate. So the same object, if it is the same point, if it is moving to new location, let us say the new location, the same point, I am denoting with p star. Try to understand how I am denoting all these things. P star, p is the old point, the corresponding new point is p star. So now p star, what will happen to the p star coordinate? Can anybody tell me? So if the old coordinate is x for x, I have to add this distance dx. So let us say p star, the coordinates are x star. I'm denoting the coordinates like x star comma y star. This is how I am denoting x star y star. So now I can say that x star is equal to this old coordinate x plus whatever is the corresponding x directional displacement that I would like to induce, that I am going to add it dx. So this is the background calculation for the moment. So the same calculation I need to, similar kind of calculation I need to perform on the y coordinate as well. The new y coordinate of the point would be old y coordinate plus y directional displacement dy. This is how I have to calculate all the, for one point, this is the calculation. Similarly, if you have 5 points, for all the 5 points, the equations are same, x plus dx. Only thing is, instead of x and y, I can say that if there are 5 points, x1, y1, x2, y2, x3, y3, like that, I can say 5 coordinates. For every coordinate, the calculation would be the same, x1 plus dx, y1 plus dy, x2 plus dx, y2 plus dy. That is how, even the here, instead of x star, x1 star, y1 star, like that you can make use. So this is the background calculation corresponding to translation. So if you look at the whatever that I said, the same thing here. So p star, x star comma y star. In a normal practice, that is how we denote the coordinates of any point, right? P star is the new new point, which is denoted with the x star y star, where x star is equal to x plus dx, y star is equal to y plus, where x and y are the old coordinates, x star y star are the new coordinates after translating. But here this is the regular calculation, but for graphics related calculations, everything needs to be converted into matrix form. So in matrix form, the coordinates would be generally shown like this. Is how the coordinates would be shown, rather than horizontal with separated with comma. It will be shown like a vertical, single vertical column x star, and below that y star. This is how the points would be represented in a matrix form. Now the same thing I have to say that x star is equal to x plus dx, right? So these two equations I can put it in a matrix form like this. Now what I am going to do is, I want to separate x, y, the old coordinate I want to separate, and I also want to separate whatever the translational distances you are giving. I want to separate both these things. How can I separate it? Is very simple. This I can rewrite it like xy as one coordinate plus dx dy as another matrix. This is one matrix, this is another matrix. So translation, if you want to convert it to matrix form, it would be a summation of two matrices like this in a two-dimensional form. In a two-dimensional form, even the first matrix also. What is the order of the matrix? 2 by 1. Second matrix also order is 2 by 1. I want you to remember that for translation, for this translation for this translation, the at the base level, so far we are talking at the very basics. So the basics are coming like addition of two matrices, where first matrix is the coordinate. First matrix denotes the coordinate, second matrix denotes the translational distances. Okay, so sum of these two matrices is simply providing me the new coordinate of the point. I hope you are following. So remember that for translation, actually we are using addition. Okay, whereas if you look at the scaling, this which is the second transformation, second fundamental transformation, if you look at it, let us say this is the old object, this is the old object, and I am providing some scaling factor. This is, let us say P is the point on a old object whose coordinates are x comma y, as we discussed, as we denoted in the previous case also, x comma y. Now uh, y, x coordinate, y coordinate. What is this? This is sx, means s multiplied by x. Okay, this is neither suffix or superfix. This is actually s multiplied by x. Okay, and this is s multiplied by y. What is this sx and sy? If you look at here, this is the new point corresponding to the old point on the old object. That point has moved to this location denoted with the p star on the new scaled up object. So p star, the coordinates of the p star will become s multiplied by x, s multiplied by y, which means where s is nothing but scaling factor. So let us say if you take the coordinate as 2 comma 3, and if I say I want to scale up, this 2 comma 3 is a point on an object, and when I say that that object has to be scaled up by 3 times I want to scale up. Okay, what will happen? This coordinate 2 multiplied by 3, 6, and by 3, 9. So the same point will become 6 comma 9 in the scale. So that is how the coordinates are created in case of a scaling. Here one thing you need to understand. Yes, I'm using same scaling factor. I'm using same scaling factor for both x direction as well as y direction. So if you do like that, what happens? You can easily understand. The shape of the object will not change, Only thing is the size of the object either increases or reduces. The size of the, if you so if s value, if it is greater than 1, then the size will increase. If the same s value is less than 1, then size will reduce. But another thing that you need to understand here is, as long as you are using same scale factor for both x direction as well as y direction, what happens is, look at, there are two lines. This is one line and this is another line. What are these two lines? For the old object, let us say the original object, if you try to draw two extreme lines from the origin, this is the origin. Okay, from the origin, this is the original object. So I'm trying to draw two extreme lines so that the entire original object lies within these two extreme lines and touches at two corners. So that is how, if you draw two lines like this for the original object, what will happen is, if S is greater than 1 and same for both x direction and y direction, as I told you, the object size would increase. Even the increased object also will maintain, will appear within the same two extreme lines. So this corner is touching that line and this corner is touching. Even the zoomed up object also, that corner still touches. Even the bottom corner still touches. Even uh, 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 zoomed down, zoomed down object, okay, smaller object also, as long as s is maintained same, the same thing happen, which means within the two extreme lines, uh, the object size changes within the two extreme lines. But what will happen if s is not same? If people can do operations, different operations by changing sx and sy. If the sx and sy are not same, for example, this is the original object. This is the original object. Let us say all these three are different scaling operations. All the three are different scaling operations. What is this? What is this? Can anybody tell me what is this? This is zoomed out object, which means the increased object. Of course, all the three are increased in different direction. But if you look at this particular thing, both x direction as well as y direction both got increased in a same manner, which means sx is equal to sy, and both are greater than 1, both are greater than 1. So that's the reason the size of the object got increased without changing its shape. Whereas if you look at this particular object, this is also scaling operation only. Only thing is, y direction there is no change. Y direction there is no change. Only thing is, all the x coordinates got increased, which means sx is greater than 1, sx is greater than 1, whereas sy scaling factor in y direction is not changed, which means it is simply is equal to 1. You should not say that it is 0. It can't be 0. Okay, is equal to sy direction still maintain, which means whatever is the y coordinate of the particular point, the same y coordinate would be maintained. So that can happen only if you make sy is equal to 1. Whereas x direction you want to enlarge, so in that case sx you need to increase greater than 1. Similarly, for this case also, probably x direction there is no change for the object, so sx is maintained as 1 as it is. There is no scaling factor in x direction, so which means 1. Whereas sy direction, the coordinate is increasing in the y direction, so sy is equal to greater than 1. So I hope you understood the scaling operation along with the scaling factor. So now I want you to understand the mathematics. So p star, as this is a regular coordinate form, x star comma y star. So x star is equal to sx multiplied by x, where x is the Old coordinate, old x coordinate you have to multiply with sx, old y coordinate, so this is not dy, okay, this is only a y. Old y coordinate you have to multiply with the sy. So now the same sx multiplied by x, sy multiplied by y. If you want to convert this into matrix form, this calculation, if you want to convert it to matrix form, that is how I can convert. So if you look at this sx0, 0, sy. So as a multiplication, what is happening? P star is equal to, as a multiplication, what will happen if you can easily understand? P star is equal to multiplication sx into x. This is sx into x, right? Sx into x. And here 0 multiplied by x is 0, and sy multiplied by y, syy. So sy comma y. So I hope you understood how we are transfer. So this is a regular calculation. This regular calculation only I am converting into matrix form, and also separated two separated into two matrices, where the first matrix is called a scaling matrix. This matrix is called as a scaling matrix. This matrix is called as a coordinate matrix. Why this is called as coordinate matrix? X, Y, it is simply old coordinate. Sx0, 0, Sy, it is a as a scaling factors. So by separating these two matrices, it will become very easy for the CAD tool to calculate, to apply the same equation, to perform the same kind of calculation over any number of points. Okay, so instead of xy, you can have a big matrix where first coordinate is x1 y1, second column is x2 y2, third column is x3 y3. So like that I can maintain, if the object is having some 10 coordinates, I can have all the 10 coordinates here. So everything will be a multiplication of one matrix to another coordinate matrix. That is how the advantage of matrices, matrix converting the regular calculation into matrix form. Okay, so the first matrix is represented like TS, the second matrix is represented with a P, where P is the old point, P star is the new point. T is the transformation matrix for scaling. This is called a transformation matrix for scaling. Remember, where it is denoted with the scale TS, TS is equal to Sx0, 0, S. I want you to remember all these matrices. Okay, and here scaling, we are, it is actually multiplication of two matrices. Try to understand. In case of translation, it was addition of two matrices, where one matrix is a transformation matrix. Look at here, this is a this is dx dy, this is transformation matrix for translation, transformation matrix for translation, whereas this is the p, which is a old coordinate. And this the operation that we are performing is addition of these two matrices. Okay, here multiplication. Okay, now third one is reflection or mirror. Reflection or mirror. And reflection, we know all these things, right? Already I showed in the from the previous picture itself. This is, let us say, if this is the old object, this is a reflected image of the old object with respect to x-axis, and similarly with respect to y-axis, this is the reflection. If someone asks you to reflect about both axes, that is how it will become. Either they can say about reflect about both axes, or they may say that reflect about origin also. Both operations are meant to be same. What is happening behind the screen? It is very simple. Let us take a old object, and this is a reflected image. Old object can also be called as a original object. Remember what it, you should be in a position to grab it. So let us say this is the object and this is the reflected object. What is happening to one of the point on the old P is a P star. Let us say if P, coordinates of P are x comma y, are the coordinates of the point, and if my operation is going to be reflection about y-axis, if the x-axis, if the operation is going to be reflection about x-axis, the P is changing to P star like this. So what will happen to its coordinates? X coordinate will remain same. So x coordinate means this distance. X coordinate means this distance. The same distance is being maintained even for the P star also. So x coordinate, there is no change in Ex. What is happening to the y coordinate? Y coordinate means this distance. So y coordinate, the distance may be same, but the direction got changed. Direction got reversed. So y coordinate is changing to negative. So minus y will be the new coordinate of the reflected image when I perform reflection about x-axis. So whenever I perform reflection about x-axis, minus I have to apply minus 1 for the y coordinate. Y coordinate I need to multiply with the minus 1. Look at here. So P star is comma minus y. Okay. So in the matrix form I can do like this. I can write it like this. 1 minus 1 multiplied by old coordinate x comma y. If you multiply these two, the same thing, you will get the previous thing. 1 multiplied by x, 0 multiplied means x only, x only. Now what is happening to the y coordinate? 0 multiplied by x is 0, minus 1 multiplied by y, minus y. So the new coordinates are, look at here, x comma minus y, x comma minus y. First one is a regular coordinate system, the second one is a matrix form. So that is how matrix, here you need to understand that this matrix is called as, this matrix is called as transformation matrix for mirroring. That is why I denote with the TM, TM. Okay, transformation matrix for mirroring. So here also I just separate. I have always, you need to try to separate the transformation matrix and the old point. Okay, why do you need to separate these two? It is very simple. Okay, if the object is having some 10 points or 20 points, all the 10 points or 20 points just need to be multiplied with the same TM. So what will happen is, instead of xy, it will become a 10, 2 by 10. If you are going to play with 10 coordinates, it will become 2 by 10 matrix. Okay, 2 rows and 10 columns, x1, y1, x2, y2, x3, y3, like that. So overall, the multiplication is only one time I'm multiplying. Okay, whether irrespective of the number of points, my multiplication is always going to be only one time, matrix multiplication. That is the advantage of converting into matrix form. Whereas if you want to perform the same task in a regular calculation, each and every point you have to take and you have to do the calculation on each and every point. Now the same thing, if you try to perform mirror image about y-axis, you can easily understand that now the transformation matrix will become opposite, which means that minus I have to apply for the here. Okay, minus I have to apply here, and here it will become plus. For which one? For mirror image about a y-axis. If you want to do the mirror image about y-axis, so minus will be for the top one and positive for the negative bottom one. So altogether it would be simply shown like plus or minus 1 here and plus or minus 1 here. In a general practice, in a general transformation matrix would be represented like plus or minus. So which one is plus or which one is minus, you have to remember and you have to apply correspondingly. Okay, if your requirement is mirror image about x-axis, then put minus for the bottom one. If you are about a y-axis, then put minus for the upper one. So that you have, but in general that matrix would be shown like this. Now the fourth transformation matrix is rotation. So if you look at the old object, so this is the old object, this is the old, and this is the rotated object. The Are you following? Seems some small network issue. Voice not audible. Now you hear me now?
Yes, sir.
Okay. I got some issue here. That's the reason I just. Okay, fine. I hope even the PPT also visible to you. PPT also visible, right? Okay, fine.
Yes, sir.
Okay, okay, fine. Got the message. Now, mm, let me take the attendance. I also would like to post a question here because sometimes we don't know how many are really listening or not. Especially for this class, it is difficult for me also, right? It's almost like 12:20 lunchtime, and you would have already exhausted with the previous classes. So that's the reason. It's only for my feedback. I'm just trying to post a question only to know how many are really with me or not. So only to understand the statistics. Let me post. Can you please respond to the poll? Let me take the attendance as well.
Sir, there's no poll being displayed, sir.
Really?
Yes, sir, there's no poll being displayed.
Okay, let me see. I just posted it. And I'm getting the messages also. I got around some 37 responses as of now. So try from. Who is this? Akhil, right? Akhil messaged me about some error, right? Please respond so that
Pardon?
I do understand. No issue. Even if you message me saying that you are unable to, that's also kind of response. No issue. Only to know how many are really able to follow. I'm not going to question anybody. Only to for my understanding, nothing more than that. Okay, seems okay. 38. And let me take the attendance also parallelly. Hmm. Yeah. How are you feeling about online classes? Are online classes helpful? Are you feeling comfortable or compared to the regular class? I just want to know how are you feeling? Are online classes are good or coming to the college and attending these classes are good? Only with respect to the classwork I'm telling. I'm not saying about. I'm not talking about the remaining environment. I know you may miss a lot of um college fun and all, but only with respect to classwork. Okay, fine. Okay, Sridevi and okay, Amarapa Sridevi also got some error. Okay, no issue. I think can replace traditional offline classes. Yes, better for PPT. Yes, true. Actually, from my side, I am feeling like I'm able to show a lot of material, including not only PPT but also through using videos. But whereas in the regular classes, I may not be in a position to, show all kinds of material. For learning, it's okay. Only thing is like a live interaction may be missing. Though we are using some of the tools, uh, still live interactions always will be good. But digital environment is somewhat better here. Okay, fine. Thank you for your. And I think class is till 12:40. So let me complete uh, this small topic. So once the 2D transformations are over, then transformations we can discuss in the next class. Mm. Now coming to the fourth transformation, coming to the fourth transformation, it's rotation. Okay, rotation as you can see it from the picture, it is very simple. Your requirement is actually trying to rotate an object about origin you're trying to rotate. So if you take a point P whose coordinates are x comma y, whose coordinates are x comma y, and whereas P star is the corresponding new point after rotating, and the coordinates would be x star comma y star. So this is x comma y, and this is x star comma y star. Okay, now I hope you can easily do the calculations uh, that are involved here. So our requirement is actually going to calculate x star. So x is the old coordinate and theta is the rotation angle that I'm going to provide in the computer as an input. So using x and theta, of course, what is this angle? Alpha. Alpha is another angle which is actually corresponding to a particular point. If I take a point x comma y, I know how to calculate alpha. It is simple, right? Tan theta is nothing but y by x, right? Tan theta, tan alpha. If this angle is alpha, tan alpha is simply y by x. So alpha is equal to tan inverse y by x. I can calculate alpha angle, no issue at all. Whereas so which means if I provide the x comma y coordinate, I now need to provide alpha. Um, just a minute. See, నేను క్లాస్లో ఉన్నాను మళ్ళీ చేస్తాను ఒక 10 minutes. So if you look at it, if you look at the calculation part, so if this is r, O to P, this distance is denoted with r. If the distance is denoted with a small r, there is a relation between x, y, r and alpha, right? So how x can be denoted? X can be denoted like simply r cos alpha. X is equal to r cos alpha. You know all these uh, regular trigonometric equations, right? And y, basically y is equal to r sine alpha. I know it. These are very very fundamental trigonometric equations. But our requirement is to calculate x star. So x star, how do you calculate x star? X star is equal to, if this is radius r, the same radius I am going to maintain while rotating, right? So this O to P also would be the same radius r. So r multiplied by, only thing is instead of alpha, I am also having some additional rotation theta, which means that overall angle of this particular point P, now it is actually alpha plus theta. So x star will become r cos alpha plus theta, or theta plus alpha, anything is fine. So now you can expand this equation like this: r cos alpha plus beta, you know the equation, right? So using that equation, you can expand all the subsequent equations, which you can understand from this picture. Okay, so x star is equal to, this is what just I showed you, x star is equal to r cos alpha plus theta. If we expand cos alpha plus using that equation, cos a plus b, all those equations, cos theta cos a cos b minus sin a sin b, right? So cos theta cos alpha minus r sin theta sin alpha. Again, if you, now you can replace from the, just in the previous slide also I told you, x is equal to r cos alpha, y is equal to r sin alpha, right? So if you replace from this equation, r and cos alpha denotes x. So I am left with x cos theta. Similarly here also, minus and r sin alpha I can replace with the y. So y sin theta, x cos theta minus y sin theta. Similarly, to calculate y star, so here you can understand that, you can, from this equation you can understand that I eliminated r as well as alpha. These two terms got totally eliminated from the x star. But I use those terms to, for the calculation purposes. So later finally we came to know that from x, y along with theta, these three parameters are sufficient for me to calculate the new coordinate. I no need to make use of alpha, r, all those things are not necessary in the final calculation, final answer. Similarly, y star also, if you try to calculate, y star will become x sin theta plus y cos theta, by following the similar kind of procedure. So here this is one equation, this is another equation. So if you want to convert this is y star, right? If you want to show these two equations in matrix form, this is how it will be. This is how it will be. If you want to cross check, no issue, you can cross check. X star is equal to this row multiplied by this column, right? So which means x cos theta minus y sin theta. Look at here, x cos theta minus y sin theta. Perfectly correct. X star is equal to x cos theta minus y. Similarly, y star, if you multiply these two matrices, x sin theta plus y cos theta, x sin theta plus y cos, that's fine. So these two equations I can convert into a matrix form like this. So by by using matrix form, I could divide coordinate point. This is old coordinate matrix, and this is a matrix corresponding to the rotation. Theta is given, right? Rotation. So this matrix is called as transformation matrix for rotation, represented by capital T R, suffix R. So nothing but transformation matrix for rotation. You must remember all these transformation matrices. Very, very important. You surely get a question from these topics. 2D, either 2D transformations or 3D transformations, out of which 2D transformations are very, very important. Okay, definitely you will get a question from 2D transformation. So whenever you want to do the calculations, these transformation matrices are plays a very very key role. So you must remember. So, and in some of the textbooks, in some of the textbooks, the transformation matrix looks different. For example, rather than putting minus here, in some of the textbooks, they may put minus here, they may put positive here. That depends upon in which way they are actually multiplying. They are actually multiplying these two matrices. Why? Because in some of the textbooks, what they do is they try to use they try to represent the coordinate rather than in a vertical manner. They may like to represent in a horizontal manner like this, even in the matrix form also. There won't be any comma, just like how you represent the coordinate. In the same way, x comma y horizontally they represent, and also they try to multiply, reverse this multiplication. First they use coordinate and then they try to use the transformation matrix. So if I want to do the matrix multiplication in that order, in this particular order, then minus sine theta, you will get minus sine theta here, and sine positive sine theta there, and cos theta here. But fundamentally, the background calculations, ultimately by multiplying these two matrices, the final equations are going to satisfy these two. So don't worry, even if you see some these transformation matrices in a different manner. Okay. Now I also need to talk about concatenation of transformations. So in many a cases, I think we have only 4 minutes. So, okay, well, let us stop here. It's already also lunchtime. I don't want to trouble you too. But so far, whatever that we discussed, I want you to remember, without which next class would be very, very difficult, because some calculations and some matrices you need to remember, right? So I want you to go through, and we have 1 week time also. I don't want you to forget it. If you forget it, it would be difficult for me. Okay, fine. I will stop here. And let me see the responses now. 47. Hmm. So around some 13 to 15 students are sleeping, or they left. Okay, fine. I will also try to do the similar kind of thing even for the 9 to 10 or 10 class also. Probably with the live attendance might be much higher for 9 to 10 class. Fine. Okay, let us stop here. Thank you. Bye.